So my name is Hans Schipper, working at Johnson Control, based in the Netherlands. And today I will do a kind of a duo presentation. So my colleague Dirk Leibach is also present. Maybe you can have a short introduction of yourself, Dirk.
Yes, for sure. Thanks, Hans. Yes, I'm happy to join that presentation as well. My name is Dirk Leibach, working since 30 years in the field of water mist for several water mist companies in the past, being now at JCI for about nearly 2 years. I've done a lot of research work with water mist systems. And today I'm responsible for the whole product management of JCI's product line. Aqua Mist means all water mist system, to keep it as short as possible.
All right, thank you very much, Dirk. So, this afternoon's introduction to low pressure water mist systems for industrial fire protection. Here an overview of the topics that I would like to discuss during this presentation. So first of all, I would guide you through some key notes of the typical characteristics for low pressure water mist systems as they are for these specific applications, open deluge systems. Next couple of slides, we'll go through the typical highlights of what is a fryer. So what elements do these fryers contain of, and what specific parts we do protecting these industrial fryers. I will guide you through the typical approval testing program as we have done according to the FM 5560 fire test protocol, and I will take you into a specific project application which we have done with one of our partners in industrial fire protection projects. Also, we'll highlight on the system approved components. As already mentioned before, the basic is NFPA 750 for all these water mist systems, but they refer to approved or listed components used in your specific projects or systems protecting, in this situation, industrial fryers with water mist systems. And next, I will show you a bit of progress we made on a couple of projects. So some site pictures of the actual fryers. So the picture you can see here, that's the first picture I want to show you. That's basically a takeout area, and I will bring me to the next slide where I will explain a bit on the characteristics of these low pressure water mist systems, specifically for industrial fire protection systems. The objective for these systems is typical the extinguishment of fires. Mentioned before, these are all open deluge systems, specifically for class K fires, so the so-called cooking oils as defined in NFPA 750. One of the objectives is, of course, flame cooling and oxygen displacement in order to extinguish your fire, as well as radiant heat blocking in order to cool down the periphery of the fryer itself. All these systems are based on fire testing to FM 5560 and can be found in detail in our DIOM, so the DIOM TFP 224, specifically for industrial fryers. To the nozzle, so that's actually the main part of these systems, a specific developed nozzle. We call them the AM31 nozzle, which has a minimum design pressure of 11.6 bar, resulting in a flow of roughly 14 liters per minute per nozzle. The overall average system demand flows for typical fryers, as we have seen them in real life, is somewhere between 200 and then 600 liters per minute as a total system demand flow. However, the FM 5560 describes as a minimum discharge of 10 minutes. In real life, you mostly see a discharge time of 30 minutes. Pipe sizes for these systems are roughly main pipe from pump unit all the way up to the fryer is a 2-inch pipeline, and the actual nozzle pipelines are 28 mil or 1 inch in pipe size. Next slide, I would like to give you a bit more idea of what is an open value system. What is 14 liters per minute? It's already mentioned, based on fire testing to FM 5560. We as Johnson Controls developed a specific nozzle, as you can see here on the right top side, with a unique spray pattern. And I want to just show you the discharge of these nozzles. So this is really 14 liters per minute with an average droplet size of 150, 200 microns. Moving on, so what is an actual industrial fryer? I want to highlight on a couple of main areas that we are protecting with our Arcomis ULF systems. So these industrial fryers are mainly large cookers of food products installed in industrial environments. For all these fryers, oils are mostly used as the cooking medium, and you can have oil fryers up to 20,000 liters of oil in the actual pan. So the 4 main areas as typically we see in those cookers are the primary cooking area, a takeout area, a fines box, and exhaust stacks. On the next slide, I will highlight where we do find these main 4 areas to protect. So the primary cooking area, that's actually the area where you will have your oil pan with the oil level as well as the hood. So this is the primary cooking area as it is described in the FM 5560 test protocol. Next, of the main areas that need protection is the take-out area. So that's actually where the product comes out of the oil cooker. And a fines box, more or less, that's the oil filter in order to filter your oil through the oil cooking process. And as last, we do have the exhaust stacks, where you will have the exhaust of your cooking vapors. So that are the main 4 areas that we can protect with our Arcomis ULF systems. So going into the actual fire testing to FM 5560, these tests are done to Appendix J, so fire test for water mist systems for the protection of industrial oil cookers. And to give you a quick overview of the tests that need to be done, based on the actual test protocol, it is the idea to have 3 different mockups. You have mockup A, that's a large pan of 2.4 by 2.4 meters as a mock-up for an oil fryer. And mock-up B, we have a pan with 2.4 meters wide and 4.8 meters long, and a mock-up C of 2.4 meters by 7.2 meters long. So these three different mock-ups you have to do the actual fire tests on, but in total, a series of 6 fire tests has to be done, meaning each mock-up has to be tested and in a situation with the hooked position up as well as the hooked position down. So for all 3 mock-ups, tests have to be done for a hood up position as well as for a hood down position. So and based on these variety of extensive tests, we have seen that for fryers to a width of 2.4 meters, we can protect fryers with a unlimited length. So we can have fryers from a width of 2.4 meters up to 7, 8, 9, 10, even 15 meters length. So a couple of fire test approval criteria as written down in the FM 5560 test protocol. All these tests are based on auto ignition temperatures of the oil. So the auto ignition temperatures fires inside the cooker mock-up should be extinguished regardless of the position of the hood in the up position or in the down position. Next of the fire test approval criteria is the need for extinguish all open flames within 1 minute after a system discharge. One of the other criteria is actually that it's not only extinguishing of these fires, but also you have to prove that you can cool down the oil temperatures within 2 minutes below its oil flash point. Already mentioned before, duration shall be minimum 10 minutes, and at the end you should really be able to extinguish fires and have no excessive fire flare-ups or micro explosions after a while. So so based on the FM 5560 test protocol, we have done more than 50 full-scale fire tests at our test facility in the US, where we have 14 tests witnessed by FM Global. So, and to give you a short overview, so what is actually done during tests? Just to give you an overview of a actual test we have done. So what you see here, and I will show this movie twice. What you see, all orange, red are high temperatures in order to extinguish the flames and to cool down the actual temperatures. Oh, sorry. So the setup was the mock-up with 2 nozzles, so 2 rows of nozzles with a pre-burn time of 30 seconds, discharging water and extinguish the fire within 10-20 seconds. And it's important to have a even longer discharge time in order to cool down the oil temperatures below its flash point, as well as the fryer itself, so the complete fryer will be cooled down.
Additionally, I would point out that you can see in this picture, in this heat radiation picture, very well the temperature of the water, which is black. It's about 20 degrees. Yes, and that already within this 1 minute, the fire has been extinguished. Nearly the whole surrounding of that fryer, means the metal, has been cooled down very effectively in only 1 minute. And what you mainly see is the heat remains in the oil, which is the yellow shadowed part of that photo or that film. That's really amazing what water mist can take out and cool down this surrounding here.
Yeah, you can achieve tremendous cooling capabilities using water mist.
Which again is amazing. What you can see, the water does not really impinge below the oil surface. Means what we all know normally, the water, when you rush a glass of water in oil, it will explode. Due to the fine droplets, all this evaporation in the oil will not take place, as the small droplets remains on the surface and does not dig into the water itself. So this explosion will not take place with water mist.
Yeah, thank you for the add-ons. So the next slide, I would like to show you how these tests actually has been proceeded. So this is also a fryer up to 2.4 meters wide with 2 rows of nozzles. This is the smaller one. So in total, 4 nozzles. So that's roughly 50, 60 liters per minute total. Where you see over here the actual heaters, and now already some flames come up. So the auto ignition temperature of the oil is reached already, and flames will be detected due to heat detectors. There is a pre-burn time of 30 minutes before discharge.
No, 30
seconds.
Yeah.
For the actual discharge. So pretty big flames already coming up.
Probably we need to point out this pre-burn time, which is given by FM 5560.
Yeah.
Should bring the system on a very safe side, because in the real world, yes, the heat detector has detected already quite a long time the relevant heat level, and this means in real life case, the water mist system has been activated far before the 30 seconds. Yes.
Yeah, correct. And what you see after discharge, really 10-20 seconds, the flames, the fire is extinguished, and what you see overall is just water is what is vaporized. So explaining the whole process in this overall schematic, explaining a bit. So the red dotted line is the auto ignition temperature of the oil. The average oil temperatures, the black line over here, the maximum oil temperatures, the blue line over here. And as already mentioned, here first oil will reach the auto ignition temperatures, and you will see flames coming up, and at the end all oil is started ignited, and you will have a huge flame development. And there you have the 30 seconds pre-burn time. Then the actual system will activate and discharge water, where you see that within 20 seconds the actual flames are extinguished. And as to the FM5560 protocol, you have to cool down the oil temperatures below the green dotted line, the flash point, within 60 seconds. So that's the overall schematic of the tests we have done, as you have seen before. So now we come to the actual project application. I just want to take you through one of the projects we have done recently in industrial fryer protection. A fryer of 13 meters length, 2.4 meters wide. What you actually can see on the picture here, this is the fryer, and these are the stacks of the fryer. This is a typical conveyor fryer, which can handle 20 tons of fries per hour. And this was designed and installed with in total 26 nozzles, 2 rows of nozzles installed under the hood in your primary cooking area. These systems were designed to 2 zones per fryer. Zone 1 is actually the fryer itself with stacks, as well as with the exhaust, the takeout area, and a separate zone for a filter. So this is the actual filter, and from the past we have learned that the most hazardous areas is not the oil itself, but it can be crumb buildup or a product that is not going fast enough through these fires. But in specific situations, these filters could be a potential hazard. So therefore, we divided these systems in 2 zones. One zone is the actual fryer, exhaust stacks and takeout area, and a separate zone for the filter area alone. For this specific project, the total flow demand requirements were roughly 360 till 400 liters per minute, with a minimum of 10 minutes discharge. And the activation is done by heat detectors, which were installed in the hood and in the stack and in the filter itself. So the next slide, a typical schematic overview of the main components used in these industrial fire protection systems. Again, these are pump-based systems, low pressure centrifugal pumps with the alarm valve, a specific developed alarm valve for 2 zones, one the fryer, exhaust stack and takeout area, and the separate zone for filter areas. The overall system comes with detection, audio and visual alarm, heat detectors in the hood installed, as well as in the exhaust stacks, and an optional flame detector can be installed at the takeout area of these fryers. And of course, the specific developed and designed AM31 nozzles to be installed in the hood area. As mentioned before, as is also mentioned by the previous speakers, it's all about tested and approved system, but also about tested and approved components. The FM5560 protocol is not only about fire testing, but it's also about component testing. So an overview here of the main components used in these industrial fire protection systems: a pump unit, the approved nozzles, the piping system, the G-press stainless steel non-corrosion or corrosion-resistant G-press piping systems, alarm valves, and the nozzles, and these do hold a third-party approval, minimum as the FM approval, but most of these components do hold UL listing and VDS approval as well. So going back to the actual project, I would like to go a bit more in detail and to give you some side pictures and examples. So this is the overall installation, and you can see this is not just a fryer, but it's the complete installation, process installation from potatoes to French fries to the packing machines. And here you see again the 13-meter length of long fryer with exhaust stacks and the filter. So this is, as mentioned before, the take-out area. So where the product, the fried French fries come out of the industrial oil cooker, and there is additional protection required. Where you see here a test during commissioning with actual fries, and here you see a cold discharge test of this installation. And in order to give you a bit more inside detail on how these nozzles will discharge, again a short movie. This is a cold discharge test during commissioning, just to give you a good overview. So roughly 14 liters per minute per nozzle. Next slide. Again, here is a picture of the takeout area of one of the fryers. And here you see a cold discharge test for one of the filters, which I will show you a movie as well. So to give you a good idea what these low pressure nozzles discharge, and you can see 13, 14 liters per minute. Next slide. As I mentioned before, during testing you have to test with the hood up and the hood down. These fryers all do have movable hoods, basically for maintenance reasons. But as you can see here on the left picture as well. So you have your water inlet that is connected with a flexible hose, and you can imagine if the hood goes up and goes down, you have to have a flexible connection for your water supply. So one picture, a total overview of one of the projects we've done is the so-called pump room. So this is separated from the production area, where you have your water tank based on minimum 10 minutes discharge. And this project, we had two production lines, so 2 pump units and 2 valve stations per fryer line. So 1 for zone 1, the actual fryer, and 1 for zone 2, the filters. And that was all duplicated due to the reason that they had 2 separate production lines.
So one addition, Hans, maybe you can go back one slide. I think major important is also as here, although it is a low pressure system, we do also like the high pressure or hybrid system. The piping is stainless steel, as you can see on that photo. And this is one of our key things we should point out with water mist systems in general. This is a long life technology, let me say the manufacturers and players in that field having approvals, as Mark mentioned already, they use stainless steel piping, which is really a benefit for the customer, that this is a really long-lasting installation.
Yeah, and in addition to that, specifically these environments we have in the food industry, there's also high demand for corrosion-resistant materials.
Yeah, and I think Mark, you agree that this is also quite important for offshore applications, and what you have shown, I think that's one of the major key items, that the technology is reliable and is lasting for a long period on its place where it's used. Okay.
All right, next slide. So I just want to highlight that we discussed or spoke about centrifugal pump units, but for these systems, there is also an option for standalone systems in situations where power supply is not that reliant, and there a standalone system with nitrogen cylinders and a water tank can be an option for the smaller fryers as well.
That's quite a similarity to Anne's presentation for the cylinder system used for machinery spaces. It's more or less the same methodology behind. Sorry for that. So you have water cylinders or water tank and a propellant, which Anne absolutely greatly explained, which pushes out the water to the nozzles. And yeah, just to see, it's a different way that the water is not stored in high pressure cylinders. It can be stored in such a tank, which is a low pressure one, and that's just let me say the difference is the size and the type of water storage tank, not more, not less. The principle, water to store and to have these standalone systems, is exactly the same with with high or low pressure systems. Yes.
Okay, so wrapping up, summarizing, we can say that that these low pressure water mist systems are FM approved and protecting or even extinguish the fires in the industrial deep fat fryers, but it's not limited to only one fryer, so we can deal with a couple of single of deep fat fryers in a single facility. So at the end, these are all large scale industrial fryers up to 2.4 meters wide with the unlimited length of these fryers. and it's not only protection of the primary cooking area, but also can give you protection to the takeout areas of these fryers, exhaust stacks, fines box or filter units, and possibly any other components that need additional protection. As mentioned before, we can protect a unlimited number of oil fryers, oil cookers, with a single water supply. So meaning in practice, you have one single water supply with a pump unit. You calculate the hydraulic calculations based on the largest fryer or the largest hazard. And based upon that hydraulic calculations, you can select a pump unit and a water supply, and then you can protect several fryers within your system. We have done a couple of projects right now with one single water supply, one single pump unit, up to 18 fryers of protection. And for sure, it's not discharge for more than one fryer at the same time. But the advantages of having pump-based systems, you can have protection for several fryers using just one single water supply. And of course, these systems guarantee you a minimum business interruption cost potential, as already highlighted in previous presentations as well. These are water mist systems, so using water, and basically for these industrial fire protection systems, if there is an incident, your system will activate, will discharge, will extinguish the fire. You will stop your manufacturing process, and basically when the incident is done, the fire is extinguished, you could clean up and restart your process again. And don't forget, these are all processes 24/7 during the week. So if there is an issue with a fire incident and you will have production loss, then you will have huge cost issues, and also with your insurance companies. So, completing, summarizing on general water mist systems, it's only using water, so it's basically not harmful for us as humans, but also not harmful for the actual production process. But also your installation is just not water. It's not any kind of chemicals that you will introduce that could disturb your machinery as well. And water mist systems are, of course, an eco-friendly green technology, and compared to other fire protection alternatives, water mist uses a very low water demand. So again, thank you very much for this opportunity. Should there be any questions, you can contact myself or Dirk Leibach by email, and we will answer your questions and help you with your possible requirements. So thank you very much so far. Can I hand over to you, Mark?
Sure. Thanks, Hans. Thanks, Anne, for your presentations. They were most informative. I think we've answered most of the questions. There is also an excellent FAQ section on the IWMA webpage that addresses a lot of the questions. But if anybody has further questions, either contact the IWA or the presenters themselves. And once again, thank you for your participation. And sorry to overrun by 9 minutes, but hopefully you found all presentations informative today. Thank you and goodbye.